Well, here we are, the end of the beginning. If you have joined me before, this final chat is a little longer than usual and hopefully a little bit more informative. I share the sentiment of the 19th century astronomer Sir John Herschel, who once wrote in a letter to his wife, "Light was my first love." Our sun is an ordinary normal star whose temperature is 10,000 degrees Fahrenheit at its surface and 16 million degrees Fahrenheit near the center. Solar EM energy, infrared heat, light, UV, X, and gamma radiation, comes from the conversion of hydrogen to helium in stars' interiors. Over 90% of our local stars are thermonuclear fusion reactors, burning hydrogen and helium, producing the EM radiation, which is the energy that drives the universe. If you develop an interest in outer space, please also consider my face-to-face or internet astronomy courses. Let's discuss in Module 11 the periodic table of chemical elements. There are only 92 types of atoms that exist in nature. Through their electron and proton reactions, those atoms combine to form all known things in the universe. Everything in space and everything here on the planet is made from the same 92 types of atoms. No doubt some of you are skeptical. After all, even though we can see the light from the stars, we know that many of them are hundreds of millions of miles from us. And since we have never physically been there to gather samples from, how do you figure you know the physical structure of these objects? Thanks for asking. The science of the analysis of the ways in which matter emits and absorbs EM radiation, or light, is called spectroscopy. EM radiation can be quantitatively analyzed with a combined set of instruments termed the diffraction grating and the spectrograph. This all started when Newton discovered the color rainbow of light in the atmosphere was coming from the sun itself, and he termed it the spectrum of light, way back in Module 7. When any of the 92 atoms are brought to temperatures that turn them into a gaseous state, it forces the atoms to emit radiations from their interiors. Moreover, these emissions are in the color spectrum range, and when analyzed in a spectrograph, show each element has a characteristic unique spectrum of colored light bands. Its DNA fingerprint, if you will. This work, in my humble opinion, is the most important physical invention in the history of astrophysics. Seriously, we can sit in our chairs and determine the chemical composition of our universe. And Twitter! The spectrograph has been refined in the past 200 years since its invention, to the point that information on the structure, temperature, composition, condition of matter, magnetism, and directional motion of a star can also be deduced with light emissions from atoms. The Hertzsprung-Russell diagram is a graph on which the intrinsic brightness of stars are plotted against their surface temperatures. This is way too much crazy stuff for the end of our survey course. Just understand that the HR diagram was one of the most important theoretical astrophysical tools invented in the 20th century. And leave it at that. want to end this last talk with a sincere thank you for, for participating. And I hope you garner some good vibes from it about the joy of learning. So let me close with a little nugget about the mysterious black holes in the cosmos. I hate to break it to you, but black holes are neither black nor are they holes. Only in astronomy, my friends. A black hole is the collapsed core remains of an old, large, heavy star that has been reduced to such a small size that its gravitational field is now so strong, nothing, not even light or EM radiation, can reach escape velocity to leave the gravitational pull on the surface of the star. Therefore, we cannot see it. We detect them by measuring regions of gravitational strength in space. Albert Einstein first predicted black holes in 1916 with his general theory of relativity. The term black hole was coined in 1967 by American astronomer John Wheeler, and the first one was discovered in 1971. Stop by my office anytime, and I'll be more than happy to share with you. Thank you.